What if we told you Mars isn't as dry and dead as it looks? Beneath its rusty surface lies a hidden treasure, giant reserves of frozen water, waiting to be tapped by future explorers. This isn't science fiction, it's real, it's been discovered, and it could be the single resource that makes living on Mars possible. So, where is this ice hiding? How did we uncover it? And could it really fuel rockets and sustain colonies on the red planet? Let's find out. Before we talk about ice, let's picture Mars itself. Imagine standing on a dusty plain, the horizon stretching endlessly under a salmon-colored sky. The ground crunches beneath your boots, coated in rust-red dust that's been sitting here for billions of years. Mars is a world of extremes. On one side of the planet there's Valles Marineris, a canyon so vast it makes Earth's Grand Canyon look like a crack in the sidewalk. On another, there's Olympus Mons, the largest volcano in the solar system, rising nearly 14 miles high with a base the size of New Mexico. But the beauty is deceiving. Mars's atmosphere is thin, 95% carbon dioxide, and completely unbreathable. Temperatures can swing from a mild spring day near the equator to deadly cold at night. And when the winds rise, dust storms can wrap the entire planet in a red haze that lasts for months. Still, Mars wasn't always this way. Billions of years ago, rivers and lakes carved their way across the land. The evidence is written in dry riverbeds and ancient deltas. Today, liquid water can't last on the surface, but ice has survived, and that discovery is what's changing the way we look at the red planet. Our search for Martian ice has been like solving a giant puzzle. Back in 2002, NASA's Mars Odyssey spacecraft detected hydrogen signatures that pointed to large underground ice deposits. It was the first real evidence that Mars wasn't completely bone dry. In 2008, the Phoenix lander landed in the northern plains and dug into the soil. Within days, it scraped up chunks of ice, confirming that frozen water was right beneath the surface. Then in 2018, scientists spotted something breathtaking, massive cliffs where pure ice was exposed. Imagine walking up to a Martian canyon wall and seeing shimmering blue-white ice staring back at you. Suddenly, ice wasn't just theory, it was visible. And in 2020, the biggest surprise yet. Data suggested buried ice close to the equator. That matters because the equator is warmer, sunnier, and much friendlier for human exploration. Even meteorite impacts have helped us out, uncovering fresh patches of ice in newly formed craters. Nature itself keeps proving the maps right. So, where is this Martian ice hiding? At the poles there are massive frozen caps, the largest known stores of water on Mars. But the poles are brutally cold and unstable, not exactly the best spot for a base. In the mid-latitudes, ice hides underground in craters and beneath layers of dusty soil. These could be accessed with drilling, but it won't be simple. And then there's the equator, where buried ice could be close enough to reach. If confirmed, this would be the jackpot. More sunlight, warmer conditions, and easier access all mean astronauts could realistically set up camp nearby. Wherever we find it, this Martian ice isn't just frozen water. It's the foundation for survival, exploration, and the first real chance to turn Mars into a place we can truly live. Water on Mars isn't just about quenching thirst. It's about building a future. Think about it. Water can be filtered for drinking, used to grow food, and even split into hydrogen and oxygen. That means not only air to breathe, but rocket fuel to take us home. Or maybe onward, to deeper space. It also means independence. A Mars colony relying on its own ice wouldn't need constant shipments from Earth. It could survive, expand, and maybe even thrive. And beyond survival, there's science. Ice records Mars' ancient climate, holding clues about when rivers flowed and whether life could have existed. Studying it could help us answer one of humanity's biggest questions. Are we alone? But here's where it gets even more interesting. In 2015, dark streaks appeared on Martian slopes during warmer months. Scientists studying these features, called recurring slope linei, discovered hydrated salts, suggesting that briny liquid water might sometimes seep across the surface. It's not the rivers we see on Earth, but it's a hint that Mars isn't completely frozen and dead. If briny water can exist, even temporarily, it raises the chances that tiny microbial life could still hang on in hidden pockets. And for future explorers, that discovery could open the door to new resources and new challenges. So what does all of this mean for us? It means ice is shaping the entire roadmap of human exploration. Picture this: astronauts landing near an ice-rich crater at the equator. They set up a small base. Solar panels power heaters that melt the ice, turning it into clean drinking water. Some of that water is split into oxygen, filling tanks for breathable air. The leftover hydrogen is stored as rocket fuel. With that, Mars isn't just a destination. It's a stepping stone. A place where we can refuel and push further into the solar system. NASA and ESA are already looking at these possibilities as they plan future missions. Equatorial ice, if proven, could be the reason humanity's first long-term colony doesn't just visit Mars, but stays there. So here's the bottom line. Mars isn't just a dusty, lifeless rock. It's a planet keeping secrets that could unlock our future in space. We've found the evidence, we've mapped the ice, and now the question isn't if we'll use it, but when. Because somewhere under those rusty plains and ancient canyons, Mars is holding on to the resources that may one day let us call it home. If you enjoyed this video, leave a like, share, and subscribe to our channel. And don't forget to turn on the bell button, so you never miss out on the latest space discoveries.